Hello everyone. So today we are going to talk about a very important and very interesting topic of your class 11 chapter structure of atoms. Now the topic is called the photoelectric effect. The basic idea behind this photoelectric effect is your Planck's theory. And we know that in case of Planck's theory, what is it? Chalo simply एक चीज बोल देते हैं simply. So what we have in Planck's theory, what it says. So there is let's say more than one energy levels are there. So let's say this is your initial energy level and this is your final energy level. Now what happens when you have an electron here? If you provide a sufficient amount of energy or the photon or energy, whatever, let's say this is your h nu, then what will happen? This electron will go to the excited state. Okay. Now similarly, once this electron comes back from the excited state to the ground state, in a similar fashion, it will radiate the some amount of energy. Now, this is basically on the basis of the Planck's theory, and what he said is that energy will be is equal to mind of hc by lambda, where lambda is basically the wavelength of the incident radiation, or we can write from here h nu. Okay, so this is the very important working equation derived from the Planck's theory. And remember beta, this is only for the one photon. But if I have, let's say, the n photons, n number of photons are there, then what we can write beta, E is equal to your n into hc by lambda. Okay, so this is because the photoelectric, this is the basis of the photoelectric equation, that is the photon. Okay, now coming to this thing that Albert Einstein thought in different ways, so that in that time, every time people say that there is a dual nature of light. Somebody say that the particle nature is there. Some group of scientists say that there is a pure wave nature is also there. And if you see the black body radiation, which was one of the application of this Planck's theory, and that says that light has a wave character. Double slit experiment was also there, that light has a wave character. But there was in 1919, I will mention the year, in 1919, Albert Einstein, what said? He did an experiment. The experiment is what? He took a metal plate which is having a very low ionization energy, and over that metal plate he gave the incident radiation. Now while doing this, what happened as an effect, what he saw is that electron was coming out from there. Very interesting observation. See, we just here modeled the same way here. What happens, the low intensity of light, what you put into the metal surface, then what happens, the some amount of, and what the observation he got, that electrons are emitted only after some time. Now I will point here this particular point, that is after some time. The question is why? Okay, and in order to answer this, you need to think in this way that by electron though is never present at the surface, right? Now the electron is present where? Okay, so if I go by, when I just keep a pause on this topic, तो हम देखेंगे यहाँ पे कि बेटा this intensity is, let's say, your h nu, that is the intensity of the energy of the incident radiation, and electron emitted means they will be emitted by their kinetic energy, that is basically your half of mv square. So half of mv square, that means in principle what it should be, if I want to follow that it values the law of conservation of energy, then beta ये होना चाहिए था ना, half mv square. This is expected, okay, this is expected, but this does not happens. Actually what happens? Actually, you can see here it is given the electrons are emitted after certain time. That means remember one thing always here, your h nu definitely will be greater than half of mv square. And here actually everyone thought of the point that, okay, actually what is the problem here? Now, in order to explain this, I need to, let's look into the more detailed picture. Let's say this is a metal surface. And in this metal surface, under this metal surface, at a particular bulk state, this is known as the bulk region. In the bulk region, where your electrons is there. where the electron is there. Okay, now what happens once the radiation is incidented on the surface by radiation amount of h nu? What happens? It has to provide a sufficient amount of energy. It has to provide the sufficient amount of energy to this electron, which can directly go to the surface. Now see, if I go use the Planck's equation here, or Planck's theory here, so that let's say if this is the one energy state, let's say E1 energy state of the electron, and let's say the surface is the E2 energy state of the, say, then what he has to do, the electron has to basically here, in order to excite this electron from ground state to the surface, then you have to provide delta E amount of energy. Now this delta E amount of energy, from where the metal will get? This that will get from this photon, and that is why this energy which is required from the electron move from the bulk state to the surface state, this is called your work function. This is called your work function, and this is denoted by W0. Okay, so definitely in order to make this jump from E1 to E2 state, basically this energy or this work function will be associated with the frequency, and so what we can write, this is equal to h nu 0, and this frequency is called your threshold frequency. This frequency is called your threshold frequency. Threshold frequency. So revising the equation of your photoelectric effect, what we can write, h nu is equal to h nu 0 plus half of mv square. Okay, this is known as the photoelectric equation. Now see, if I want to draw a graph here, the x-axis will be the kinetic energy of the molecule, the kinetic energy of the electron, and this side, let's say, the frequency, the incident frequency, if I want to draw. Now what will happen? Okay, it's very simple and very interesting also. What actually happens here, you see that when you give a radiation, when you're giving a radiation, okay, at some point of time, after some time, the electrons are getting emitted. That means the electrons has to take some amount of frequency up to absorb, so that it can go from this bulk state to the surface state, right? So technically here, if I start initially, when the frequency, we start from here, then what will happen? After certain time, after certain point, when the frequency matches with nu 0, then after that the kinetic energy rises. Okay, and remember this thing always, this threshold frequency or this work function is, remember always, it is specific for specific metals. And another point is here, the metal which they have used, remember this metal will have a low ionization energy. It will have a low ionization energy. Okay, so that's it from my side here. If you have any questions regarding the photoelectric equation or photoelectric effect, feel free to write in the comment section. So bye everyone, take care and make sure to revise some MCQ problems from here. Okay, chalo, bye.